Good morning, Microverse. This is Mr. Foos coming back to you over the silky smooth airways, and today we have another episode of Fun with Foos. I know it's been a while. I'm like 3 episodes behind on on Fun with Foos. I was sick twice in October. It was kind of a throwaway month, to be honest. And then I tried to get back in the groove, and I wasn't liking how the work was coming out. So I'm finally here, and I think I'm just gonna do like back-to-back episodes, all in this this Davis Library room. Um, It'll be like when there's like Disney Channel Friday night specials where you get like a 2-hour special of Wizards of Waverly Place. You might have also noticed I have increasingly more of a beard. I don't know if I'm going for No Shave November. Because growing a beard's kind of a strange thing. You lose sensation in your face very quickly, and that's scary. It's kind of uncomfortable. You also kind of look like a savage. So I don't know. Maybe it'll stay. Maybe it won't. We'll see. But for now, we have homework to be done, and we have econ to be learned. So right now we are working on this homework 6. So this was the introduction to production stuff, and my general outlook is it's pretty much the same for a good while, just with replacing X and Y with L's and K's, and I truly believe that it is kind of that simple. So we can get back into, okay, I haven't used the pen in a while. So I think, interestingly, we had a question some of this on the first midterm, and a bunch of people missed it. I think this is like one of the easiest questions that you can get. So this is just like a testing your derivative understanding, and what I would look for is total product increases. So what that tells me is that we have a derivative happening. You told me either increase or decrease, like we're going in a direction. So total product is the equivalent of quantity in this scenario, like we're producing more stuff. So how I would see total product increases is we use more labor. So that just tells me like labor gives us more stuff. And I think intuitively, like that matches up with dq/dl. And just as we did last unit, or like last section, this can also be written as the marginal product of labor. So like for every time I use a labor, I get more product. And then the next step I would look at is we have this diminishing marginal piece. So remember that was like relating to, I guess when we saw like diminishing, we were taking curvature. That was often a common application. And we also have this term marginal. And remember, marginal means derivative. So what that tells me is that like labor something marginal. So my best guess is that we're taking another derivative right here. I think this is the proper way I write it. Wait, yeah, boy, okay. I guess specifically what that means is like a diminishing marginal return. So I think it's asking us like the rate of change of your MPL is like really what that's asking. Like a diminishing level of marginal return. But I think the core stays, so you could also write this as dMPL DL. And I think we had similar questions to this. I do not believe that this question is that crazy. And there's also a help sheet that I'll just throw in now. It is on which derivative do I use? So I think I'll reference this particularly on the curvature piece as well. But I think we got the stuff right here that we're we got these definitions pretty locked in. Like I don't think it should be that tricky. And hopefully that question should be pretty easy for you too. So on these types of questions, I don't have returns to scale. So returns to scale are a problem you will likely see on the midterm, and basically what it's asking is it's asking your relationship between your inputs and your outputs. And like, am I getting a good rate of exchange? Kind of like, are my inputs giving me more in relation to my outputs? Are they giving me less than what I would expect? And I don't really want to do a bunch of algebra. I don't think that like that really helps y'all. But what I will do is I'll go to the key and kind of, highlight how I would do them. So in all of these, my first step is I always write like input on this side, and then I would write output on this side. And that's like the TL versus just having like a scaled T. And I always just do it on like a 2-column system, like I run it down. And I also want to show you guys this method of writing actual and, yes. I think so. This is the expected. I believe this is how I normally do it. So in setting these questions up, you always do like, you'll just take L and you'll take K and you'll replace them with this little parentheses TLTK, and you distribute in like any exponents. I make sure to put them in the parentheses. Otherwise you might forget to distribute in the exponents. It'll be a disaster. In this case, you just add a T to like the outside of the thing. And I think that's pretty easy. So from here, you'd be comparing like this chunk and this chunk, assuming that, we set up pre-standard formation. What I would do is, I think if I had it in terms of this, I might scale, like one way of solving is you could raise everything to like the 2/3, and then that gets rid of these exponents, and then you could raise like this entire thing to 2/3. And that might be a separate way of doing the algebra. I don't have like any super awesome tips and tricks for like how to do the algebra. If it ever gets kind of complicated, then I would suggest, particularly with FOIL, people who FOIL oftentimes get kind of crazy stuff in their algebra and get lost in the sauce. But really all we're looking for is the relationship between these t's, and you can often kind of intuit, like based on which exponent gets applied, like which t is going to be bigger. In this case, we had our input side was t to the 1/2, and our output side was t when we fully worked out the algebra. And kind of the best thing that I can impart to you is your inputs are like what you actually do. So I physically put in like 2 times the amount of labor and capital. And if I'm scaling my inputs by 2, then I would expect my output to also scale by 2, or at least scale by 2, like if that's a good decision. If it's a good decision, then it will be at least 2, if not more. So, when I'm getting less than that, like my actualized thing is less than what I would expect to get out, then that means that we have decreasing returns to scale. So, like, I'm kind of associating this decreasing word with like, I kind of got shafted in a metaphorical sense in the econ world, where I'm putting in stuff and I'm not getting as much stuff out. So that is decreasing returns to scale. But if this was the opposite, where my inputs, what I actually put in was better than what I expected, then that would be increasing returns to scale. Like I'm getting a deal on whatever I'm using. And I think you can really just use that format. Like my best tip is just do it in a 2-column format, and always put this like input in an actual language that you'll never forget what increasing or decreasing returns to scale mean. Because I think sometimes it can be hard to memorize like which greater than or less than sign corresponds to which returns to scale. So that is my best method of doing that. Where did my thing go? Oh, it seems to split. Can I just no. Okay, well, that's excellent. I thought they were in the same thing, but that's okay. So that's how I would tackle these in using the key. We got B. For this type of question, which of these statements is true? So just looking at derivatives again. So labor exhibits a diminishing return. Then that's asking me, I think the same as what we had in number 1, like DMPL, DL. It's not asking me is labor increasing or decreasing. It's asking me kind of the curvature of our labor. Like are we increasing at a certain rate or something? So what I would look at is this exhibits a diminishing return would tell me that we're looking at this derivative. And we're holding K constant, which would make sense because I'm deriving with respect to L. The production function exhibits a diminishing marginal rate of substitution of labor for capital. Okay, that's kind of messed up. I think that this is asking me DMRTS, DL, and DMRTS DK. And with this, I can determine the curvature. So with a diminishing marginal rate of technical substitution, that would mean that it looks something like that, like our convex pattern from before. And I would want, so what would that mean? I would ideally want these things to be, so as I go more labor, this should be less. And if I increase my K, this should be more. So that would be a positive relationship. So I think that's what we're looking for. Diminishing return. Oh, I also should add a sign to that. So I think this would be negative if we have a diminishing return. And the production function exhibits increasing returns to scale. So does that mean I have to do the LTLTK thing? Because I am not working. Oh, actually, it's really easy. Okay, that's not bad. So in their scenario, working out the algebra, I'm just going to assume that for now on, to save some time, that algebra is kind of a commonplace skill. Like you guys have got basic derivatives down and will not make too many algebra mistakes. And I don't think that I can add much value there. So they got K plus 1, you derive that with respect to L, and that's 0, which is not a negative derivative. That's a constant derivative. So it's a constant return. So that's false. In how I described it, DMRTS DL is negative. Yeah, that's what we were looking for. And DMRTS is positive. Did they in fact find that? Oh, okay. Yeah. That they took the thing and then they did the thing and they did in fact find what I would expect. In this case, they remember like how you always do these is just wherever you see an L and the K, just plug in parentheses TL and parentheses TK in the original. So it'd be like TL parentheses TK parentheses parentheses TL. And in their case, when they simplify, it seems like we got a T squared. And remember, the actual, like this is what actually happened. And this was the expected of what was going to happen if I just like scaled it all by the same stuff, that what actually happened was better than what I expected. So that's an increasing returns to scale. And that's how I would do it. So what is the answer? B? Wait. Which of the following statements is true? Whoa. Oh, it's E. Okay. We have one of those combo ones where you gotta These are kind of, I'm not a big fan of multiple choice where they like also layer on top which of the multiple choice are true. Some of the multiple choice might actually be right or wrong, and then you got like a combination going. That's despicable. That's put on your little overalls and your yellow minion costume. Oh, I saw a lot of minions during Halloween. It's been since Halloween since since I've last checked in. But number 4, we have Joe's Coffee House operates under blah 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 blah. The short run total product of labor. Okay, I'm not entirely sure. Well, labor is variable. So how would I start this? The total product of labor everywhere increases. Okay, I think what this is asking, total product of labor increases means we're looking at MPL. So if I derive this, I would get like K plus K to the 1/2. No. I would get 1/2 L to the negative 1/2 K to the 1/2. And this is in fact positive, so I believe that corresponds to increases. And then I need the rate of which this is happening. Oh, brother. Whoa. we got initially increasing at a decreasing rate, and then eventually... Okay. We'll we'll see if that's just like jargon from the question or if that would actually make sense. So I think the next piece I would do is I would take the derivative of this thing again with respect to L. So it would be like, would the K just drop off? Yeah, I think the K would just drop off. So we would get K to the 1/2. I would get negative 1/4. And then I would get L to the negative 3/2. So I believe it's definitely increasing at a decreasing rate. And I'm trying to figure out, I think it would just be A. No, wait. Let's look at, oh wait. Oh, it is just A. Okay. My little thing, sorry, I have a giant like spreadsheet over here of the answers, but yes, it is actually just A. That this one is positive, this one's negative. I think what some of these would be is like this initially increasing piece would be, let's just imagine a world where I had like an extra plus K or something, where like maybe originally I'm positive, but as I use L and this starts becoming like more relevant, this negative piece, then maybe it would like swap off. And I think that's kind of like the only situation that I can think of that would result in that situation. Okay, moving on. We got returns to scale stuff. I think this graph is the exact same one we had in a class poll. So hopefully this is a familiar thing. Okay. This is a good amount of of econ jargon, and then we're figuring out which one is false. So all of these are true. If marginal product is decreasing, then average product, I think that's true. So wait, no. Answer key does not seem to agree. So let's just get this going. That if MPL is decrease, wait. I'm trying to intuit what they're thinking, what this graph means. If MPL is decreasing and greater. Okay. So I believe definitely this one I would just cross off. You can definitely have a situation where marginal product, so average product is like your total product divided by how much stuff you've made. So inherently, wait, is that, I'm kind of lost. I'm getting lost myself. Whenever you make something, which is the marginal product, that can definitely be like, you can put a worker into the mix and they can have negative consequences. But I think what average product means is you're taking the total amount of stuff and then making an average. So assuming you've made a positive amount of stuff, then it inherently has to be positive as well. If marginal product is negative, total product must be decreasing. I think that makes sense. So for like, this is just saying, you know, for if marginal product, yeah. It's like every time I make a product, it decreases our total amount of product. That's just by definition what a negative derivative means. If marginal product is positive in decreasing, so every time I make something, it does in fact, it's a positive making something, but it's at a decreasing rate. Total product is increasing at a decreasing rate. I think that would make sense. Like, it's hard to kind of intuit what this question's getting me to learn. And maybe I'd have to think a little harder. But I think this would just make sense, that if every time I make something, it's good, and it's good at a decreasing rate, that total product would also be good at a decreasing rate. And if average product is increasing, yeah, this would make sense. So if our average is increasing, then like the only way to make an average go up, so like kind of thinking about this, let's just say we have like the most generic case of average, which I think of in terms of like a test score or something. So like, say the average test score is like an 80, there you go. Then the only way to make the average go up would be is if somebody got above an 80. So if we got like an 85, and I think that's literally just what it's asking here. So if, let's say our average product was 80, then, you know, the marginal product must be like, every time I add something, I'm getting 85 product to make that average go up. So that would leave only this one. And I don't know exactly, maybe there's if MPL, what does this have to? Oh, okay. Average product must be decreasing too. Yeah, I think why this is false is because it could be decreasing at like a certain rate, which would make it so that the trend doesn't hold. But generally on these false ones, I think a valid strategy is just to go which ones sound good and then take whichever one didn't. This wasn't even related to the graph either. That's kind of goofy. The figure above shows the isoquants. The increasing returns to scale are, so when I hop from 2 to 4, then I doubled my inputs. So dish was, let's actually write it. This might be a valuable way to think about it. So I 2x'd my inputs, and then from 10,000 to 20,000, I 2x'd my outputs. And that would be a constant returns to scale, if you're following along with what returns to scale means. On this jump, I did a 50% increase to my inputs, going from 4 to 6, and then I only got a 25% bump in my outputs. And if we remember that my increasing, my actual, is less than what I would have expected to get out. So that means I'm getting a bad deal. This is not, we should not be doing this. So this is decreasing returns to scale. This is constant returns to scale. And I would bet you that this little chunk, because I think the pattern is typically increasing, constant, and decreasing, that this part is the increasing returns to scale. And if we wanted to check this, I doubled my output and I did not double my inputs. My inputs seem to have only increased by like a little bit, maybe like a third or something, and I got double the output. So that is why it would be increasing returns to scale. You can also tell like the distance. So 10,000 to 20,000, that's like a big, that was a big distance. But this 5,000 to 10,000, which is equally a doubled outcome that, oh wait, please tell me that we have, okay, yeah, we have an existential crisis that I haven't been, I would be so upset if I was just recording my face cam this entire time and not the screen. That increasing returns to scale are present when we are below 10,000 tons. Does that line up? Yes, let's go. Quick and easy one. At the X and Y Z Co. Okay, that's a terrible name. A unit. So we know that a unit of capital costs 3 times as much as a unit of labor. So wage is equal to 3 times as much. 3 wage equals, no, rate? Wait, I think so. I think that's right. Additionally, so if I were to plug in 1 there, 1, oh brother. I'm losing it. Wait, wage. No, okay, I had it right. Okay, we're good, clear. That additionally, we can trade 2 units of labor for an additional unit of capital. So I believe how I would do that is capital to, wait. So a capital is more useful because it takes 2 labors and 1 capital. So I want the coefficient on my capital would be bigger because it provides me more stuff. That is how I am intuiting that. So I believe that would be the relationship there. So this would be like our equivalent of our MRT, and then this is how we're getting like our MRS if we're thinking in the equivalent terms, or our utility function or whatever from the last chunk of the class. Assuming production exhibits a diminishing MRTS. Oh brother. Okay. You know, I might, this looks a little fishy actually. These look like perfect substitutes, and it kind of looks like we have a corner solution. So if I were to intuit without thinking about using the key, what I would think is that labors are like half as efficient as capital when you're making stuff, but this is 3 times more expensive. So I think I would always just want labor, I think. But I might be wrong there. I might have, oh no, okay, that was a stupid move. Okay. So how are they doing it? Oh, okay, they just did a little MRTS shenanigans. I did have somebody ask me this today though, and I think maybe that's a valuable thing. Although I'm kind of wondering, I guess they didn't explicitly. Okay, that's why. So my version didn't make sense because it says the current level. So it's not saying at all levels, like it's not saying they are perfect substitutes. They're saying like at our current situation, at the bundle that we're at, this is the scenario. I kind of liked how they set it up. So maybe I'll just do a 1/3 wage times rate is the 1/3, which is your MRT. And they made the change in K over the change in L. That was 1/2. And that would line up. So MRTS was there. And a valuable thing that I believe, I'm just gonna actually let's just let's just go with the key. Let's use some humility here. So somebody asked me a question on these types where you can use bang per buck. Similarly to how we used bang per buck last time, you can use bang per buck on these types of problems too. And you can also use the MRTS method. So if you make a graph and you notice that the MRTS is steeper than the MRT, then that means that we're coming in too hot right here. And I believe it's just an always trend that if the MRTS is bigger, then you're like in the top left. And if the MRTS is smaller, then you weren't coming in hot enough. So you are always in this bottom right section. And generally, the best outcome, I think maybe I've taught this before on consumer theory, but it's always going to be in the middle of this line. That's like basically the trend that always happens. And if you just wanted to memorize, like, knowing that I am in the top left section right up here, and if I wanted to get into the middle of this line, how would I accomplish that? Then I would buy more labor and less capital. So like moving from this line, if I wanted to get to the middle, and what this graph is illustrating is, like, intuitively what I would do is I would go here, and then because we are now above the quantity, like the quantity stays set in production problems. That's kind of an interesting parallel between this half of the class and the last half. Is on consumer theory, I used to be bumping myself up to a higher indifference curve. So what it used to look like was, this would be my indifference curve 1. And then if I got a better, situation by moving to the middle, I would have moved to a higher indifference curve. But actually now we're thinking like I can make the same quantity of thing, but at a lower cost level. So it kind of works in the opposite direction, where now I'm shifting the budget that I need, like the amount of money I need to spend. But I'm kind of over rambling on, if you really just want to do this question quickly, figure out whether or not you're up in the top left or down in the bottom right, and then try to scoot yourself to the middle, and that will be the answer on which one you have. Going back to these problems. A firm's ISO quant, okay, blah, 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 blah. The MRT of capital, of labor for capital. So I think this is pretty similar to like homework 2 or something. We had, this is a common one where she'll give you the axis intercept, and then you have to tell how much you could buy total. So if this was 225 bones and I spent 25, that's 9 total capitals. So wage over rate or something, then each rate costs 9 bones because 25 times 9 is our total. And then I would bet you that the answer is 10 without doing anything else. I'm just cross-referencing the it tells us additionally the price of labor is 10. I was getting a little ahead of myself. So that's how we get this one. So this one and this one are bad answers. You don't want to pick those. And then, this is a perfect illustration of what we were just talking about. So if I'm down here in the bottom right, I want to be going right there, and then I want to be moving to a lower thingy thing. So that would tell me that I want to use less labor and more capital. And I believe that would correspond to a situation where the marginal product per dollar spent on capital, you know what this term means? That means the bang per buck. The bang per buck of capital is greater than, so that's greater than. And how I just determined that was because I wanted more capital. So that tells me that the bang per buck, the bang per buck, baby, the bang per buck on capital was higher, so I want more dem capitals, and the marginal product of labor is going to be smaller, and we can go there. So in this case, I think I heavily shortcutted by using this awesome possum method of moving to the middle of the line. I don't like commit that fully to like in 100% of all cases in economics, we're always going to shift to like if you have perfect complements or something, or you got weird stuff going on, you got weird curves, that might not necessarily be true. But I would bet like 90% of the time this moving to the middle of the line shortcut is a way to skip a lot of the bang per buck math stuff if you don't want to think about it that way. Suppose that the price of capital services, okay, what is this saying? So what I am noticing is, suppose that the price is equal to 10. Okay, well, it seems to me like labor just kind of sucks. But maybe. Maybe I'll just plug and chug. I think you can do this through, like what they give you is they give you the price of capital, and so they give you 5/10, which is the MRT. And maybe what I would go with, oh, I know exactly how I would do this. So the marginal product of labor is going to be K plus, no, it's just K. Over the wage, so that's 50, K over 50, and the marginal product of capital would be L plus 1 over 10, and I would bet you I'm trying to think. If I were to get to 20, I'm kind of running myself into circles with this. So I will just use the plug and chug method of how easy it is. Capital seems to be a way better situation. So I'm just going to start spamming a bunch of capital and see what happens. So I need to make 20. 20 is equal to KL plus K. If I wanted to just plug in, let's say 10 Ks, then I would get 10 times 0 plus 10. That would be 100 bones. And then I would spend 50 bones to get this equal to 1 because I need 1 labor. Plus 10, and that does equal 20. So I think that was the cheapest combination of how I could have made this 20. So I believe the answer is B, and how I would do that. There might be, we can go check the key and see if somebody created a more intellectual way of doing it. Yes, there does seem to be, you can use the input demand functions, I think, or something. I think that's what they're doing here. To figure out what the answer is, similar to how we did the input demands for last time. You can like plug into the bundle So you can solve, you plug it into the production equation, similar to how we plugged it into the budget constraint last time, where you do like income equals pxx, blah, 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 blah. You're familiar. And that's how they did this one. Since they kind of use really easy numbers, my method is honestly pretty acceptable. And maybe I would have just skipped to my method to begin with. But it isn't interesting if you're ever on a test and you're like, uh-oh, I don't know what's going on. I think it's a valid strategy is like, just kind of break it down. You don't even need to use like the proper ECON410 toolkit if you start getting stressed out. Just like find any basic way to intuit through the question. But on this final multiple choice question, we got Q equals, so we got a production function, we got our MRT, we got, okay, so I do believe this would be similar to, like, I do believe we should do it the way they did it in the last problem. So MPL is K squared over, this would be what, 2KL is equal to the wage, which is 10 over 20. So I would get like 20K squared equals 20KL. And then I can divide both sides by K. So I can get 20K is equal to 20L. Whoa, well, that just means K equals L. That's crazy. Is that true? Am I doing something wrong here? Maybe. But that would just mean that we have like K cubed or L cubed. Huh. So Q is equal to like K cubed. So 27,000 is equal to K cubed. Is 27,000 something easy? What is, let's see if the key has has any wisdom for me. K cubed. What's the cube root of 27,000? Is that just like a, maybe let's go ask Google. Let's see if I were doing this, I would be like cube root of 27,000 and then it's 30. Okay. So that would tell me that K is equal to 30. And then I solved from up here that K is equal to L. So L is also 30. And then when I have these two, so I know K is 30 and L is 30, then I just plug those back into whatever it cost me. So it costs me $300 for the labor. And it cost me, get your little middle tail back in there. And the dollar sign, so it cost me 20 for capital. So this is 600, and then I would add those together to get 900 bones. Doink. Alrighty. So that is the end of the multiple choice section. And moving on to long forms. So I will quickly lay out the steps of what I believe I would note. Long forms are typically like vocabulary type questions, and where L, so we're given a production function, pre-standard, does labor exhibit a diminishing marginal return? Okay, that means we're looking at DMPL, DL. That is the derivative I would use, and if it's positive, then this would be false. It would be not a diminishing return. And if this was negative, then this would be true. It does. And on this next piece, returns to scale, I would do replace your TL 3/2 and your TK to the 1/2. And then I would distribute these in or something. And then hopefully it would compare nicely to if I just put a T and then I did L to the 3/2. K to the 3/2, nope, K to the 1/2. So this is how I always set it up, and make sure above this to write like your input, and write that this is the actual. That's my tip. If you take anything away from this homework, then that's what I do whenever I write this out. So write out input actual, and then this would be output expected, and whichever one's bigger, do the comparison. I think we walked through the comparison enough, but that is what I would do. And getting rid of that so I can look at the vocab. Compare and contrast. Oh, I do remember this. This is a common thing. I kind of doubt it'll be on your midterm, but I do remember this on my own homework from 3 years ago. She likes to put these like interpretive, do you know the words here? And I think I'll just look at the key for that. I think it's kind of simple though. Like diminishing marginal returns to me would be that total, So I think one piece would be like you're only changing one good with diminishing marginal returns. So like, does labor give me like positive returns at a diminishing rate, for example, whereas returns to scale is you're doing like both L and K at the same time and seeing like, is that a diminishing rate? So that's probably the main thing I would take away, but maybe it's different. Consider, so we're just given a production quantity function thing. Okay, the derivatives right here. So what I'm reading is diminishing marginal rate of blah, 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 blah. I keep saying that. That's crazy. That is baked in. I notice I get lost in common speech patterns. I think that's probably everyone does, with the amount of slang that gets injected into our vernacular. I constantly find myself saying that someone's chopped, or you got skibbity riz, or whatever whatever is going on in pop culture. I think my vocabulary kind of deteriorates. I feel like I had more control over my language when I was like 12. But unfortunately, I get caught in the same little patterns of mediocre speech. But side note, getting back in here, I would look at DMRTS. This diminishing thing tells me that we're going in the convex thing that we had earlier. So if I were to recreate this, then as I increase my labor, this MRTS, the slope, how steep this thing is, should be getting smaller. And my DMRTS DK should be getting more positive. And if that holds, then this would be true. You get the gist. Plug in, same thing. Just do plug in, like every time I see that L, replacing it with the parentheses TL, and then I would write TK to the 1/2, everything to the thirds. Maybe how I would tackle this is I would raise everything to the 1/3, maybe to get rid of the outside thing, but that's your choice. You can do it to both sides. Algebra tips and tricks are just like, it's either you got the algebra or you don't. And on these, I would emphasize that FOIL, I think, always works. So like how you would distribute something in 8th grade, that always works. But sometimes these functions get pretty messy and complex. So I would just keep in your back pocket like a couple tips and tricks there of, maybe how you can make the algebra a little sweeter for yourself. And the last thing that we're looking at is calculate. So I think it's pretty similar. We're just looking at our MPL over our MPK. And then we're going to equal that to our wage over the rate, which in this case would be 10 and 30. It's the exact same steps you just did for this type of problem, I believe. So just copy what we did. So cross multiply, solve for one of them in terms of the other, plug back into your quantity function up here, and then make sure to set this quantity function to 64,000 because I want 64,000 units of output, and then do some solving. You should get, a K or an L or something, and then you can plug that back into the demand function that you solved for, and then you'll get both of the goods, the quantity of both of the goods, and then you just plug those in to the prices, and then you'll get your total cost, because it's asking us, oh wait, no, it's not even asking us for the cost, it's just asking us for the combination of labor. So hopefully that made sense, but I'll make like a little flow chart. So flow chart MRTS is equal to MRT, do a little cross multiplication, cross multiply. Then I would solve for L or K, doesn't really matter. And then you plug whatever you found into Q. Set your Q equal to the constraint of what it's asking me from the question, and it will always give you whatever that is. And then we'll have you plug back into whatever you found from up here. Wait, no. This step. There you go. So once you solved, you plug it back in, you should get a bundle. But as per usual, I just go through quickly. So let's see if my theories were right. DMPL yep, that is the derivative we were using. We found increasing returns to scale. They did similar format, TLTK, pretty standard stuff. They found this one was bigger, so my actual was bigger than my expected, so I got a better deal in actuality. And that is why we're increasing returns to scale. Similar, both. What were we talking about? We were talking about marginal product and decreasing and increasing returns to scale or something. Yeah, I think it's fair. So they're similar in that they're both seeing like the rate of return of something. So we're getting more quantity whenever we put in inputs, but like how is that changing? And then the difference would be, that we're changing both inputs versus one input. Maybe I bet ChatGPT could give you would give you that nugget of information if you put it in there. But I don't know for sure. I'm kind of hit or miss on ChatGPT, particularly for this class. I feel like I would just stick to the resources of whatever we have in the microverse. Some words of wisdom with ChatGPT from my experience as a student at UNC is, if your teacher kind of sucks and doesn't provide you resources to study, then I would highly advise you to use ChatGPT so that you can figure out, or I guess any AI tool, to figure out what's happening and like to get a baseline understanding. And also YouTube videos are one of my favorite ways to do that. And if your teacher has a bunch of resources, which I feel like we do have plentiful resources, and it's very like kind of niche stuff. Like we have a patented method on on teaching intermediate microeconomics in this class. So I wouldn't like try to use outside information too much. I would just stick to whatever we have, and maybe just using your brain to think through, whether or not it's one or both. And then let's look DMRTS, DLDK. Yep, that is exactly what was happening. If it's negative, which, yep, it is in fact negative, it does diminish. Okay, that lines up with what I was saying. Same steps here, and same steps. If you want the, if you want to just be a little robot on these questions, just follow the flow chart. Otherwise, I don't know. That is kind of what I would suggest. I would say I'm very good at being a little robot and just like, I want to copy the exact same steps for all these questions. I don't really want to have to think. I just want to be like, I recognize which type of problem this is, and I'm going to copy the exact same types of steps we use. And then the only variations, like the coefficient on stuff, might change, and the questions become pretty easy. But they just went down the line, solved, got a bundle, looks good. So I think that's a wrap for me. Actually, we have Polish word of the day. That's a classic. So maybe can I get my own? Can I get a little page or something? Okay. I'm gonna hit y'all with the crown jewel of funny Polish words to English speakers. So it's a common verb. You might know the verb to be. You use it a lot if you're saying like I am. You're using to be. So in Polish, this verb, the infinitive form, this means like the unconjugated version of to be, is the word BYC with a little thingy thing, and this is called bitch. So if you ever wanted to call your friend, it might be a little rude. You gotta know your friend very well if you're if you're gonna throw this one at them. But you can be like, you are the infinitive form of the verb to be in Polish, and then you are effectively calling them a bitch. And I guess breaking this down, this makes a b sound, this makes an sound, and then the C with the little hat makes a ch sound. So b, ch, bitch. So that's your word of the day, is Polish to be is bitch. But anyway, back to hello. I hope you guys enjoyed this episode of Fun with Foos. I had more fun this time than last time. I got like 20 minutes into the last recording. It was like, oh man, this is this is terrible. I'm explaining terribly. And only 56 minutes. We're under the hour mark. There will be, I guess, you guys might not be back to back watching these episodes, but for me, I'm gonna go record the immediate next homework right now. But I think major takeaways are from this homework: if you got derivatives down, like the basic, which derivatives correspond to which language, I think increasing and decreasing returns to scale, and then pretty standard, just like setting MRT equals to MRTS, finding optimal bundles, figuring out what all this stuff means. I think those are the major takeaways that I would have for this homework. And if you can redo all the homework problems, then I think you're in a great spot for this unit. Or maybe not the entire unit, the lesson of whatever this was. I have no idea what the lesson name is. But anyway, I hope you guys enjoyed watching, and I will see y'all on the next episode. And as Brad Pitt says in Inglourious Bastards, arrivederci.